This is the video for Service Center Dynamic Programming Routine. Routine starts over here on the left and ends up over here on the right, and below it are some lists that are used by this routine. It starts out by filling numerically 1 plus ng. ng is 59 because most of the loops we do go from 0 to 59. But in this case, we have to fill all 60 of them with a value. So it adds 1 to the 59 and says 60 values at best cost with this high value. That's saying all service centers are very expensive. Then it fills 60 things at best predecessor with 0, indicating there's no predecessor. Yet, anyway. Then it says set j to 18. And then it says for I2 down to next I20. It's going to want put the best value for a service center being put at position 2 through 20. It started at 2 because it's not likely there's going to be a best cost with a service center put at the very first position or the second position. Matter of fact, it's hard to believe that there will be one at the 2 position either. But we're going to start at 2 and go to 20. We set ns to I. Well, I starts at 2. ns is a control register that says how many values are involved in a list, such as this one here where it says multiply list. So at first that's going to be 2. But as we move further away from the beginning, it's going to be 3, 4, 5. Because there are going to be costs involved for that service center at that position, supplying service to all the spots before that. So we're starting out where there's going to be 2 spots before that. And here we have the spot count. That's the list down here. Those are the spot counts. For instance, the first spot has 2, second 8, third one 4, the fourth one 2. That's how many people have to be serviced at each one of those spots. That's what's in the spot count. So the first time there's going to be 2, and the factors are going to start at offset j, which here is 18. And down here we see 1 is subtracted from j each time. Well, we're starting at 18. In our list down here, 18 would be this 20 here. But it's going to go 2 times. It's going to multiply this 20 times 2, gets 40. Then it's going to multiply this 10 times 8 and get 80. And the 2 of them are 120. Then we're going to see after it adds those 2 together here and makes best costs of I, it then adds also to it the $1,000 for the cost center. So here we see not only the 120, which is the 40 and the 80, but also the cost of the center. So if a center is going to be placed at that position, it's going to cost $1,120. If a service center is placed at the next position, it's going to be $1,260. That's the best cost of putting the service center there and going and servicing all the people from that service center back to the beginning. So this loop is calculating all those best costs for the very first service center. Next, it's going to do all the other service center positions. It says for I of 5, and way over here it says next I to ng 1 at a time. It's going to go around for all the other service centers. First it says set L to the value of I and then subtract 2 from it. That's going to be used down here to see what the spot counts are. They're going to start at offset L. Then it says set K to that value of L and subtract 1 from it. Well, once it goes back to the number of spots that get charged a cost, It goes to the actual position of the previous service center. It needs to know where the previous one is at. It's at offset K. Then it sets NS to 2, because at first it's going to start, what? 2 positions away. So 2 calculations are going to have to be made. Then it says for J of 0, and down here for J to 380, 20 at a time. That J is going to be used for this multiply vectors, which will say what values to multiply times the spot counts to get the result values that we're then going to add up, just like we summed them up here for the first service center position. But now we have to go back to one of these at the beginning to find the best cost. So it's going to say multiply it by these costs, add them up, then say our test cost for this position is that cost plus the best cost to get to K. See, we had to go back here to find a previous best cost, the previous service center. At the beginning it will be these that we made here, but later on it will be a service center that it made that it's going back to. So it adds the previous cost to it, and then it also adds to it the cost of putting a service center at this position. Then it says if that cost we just found is greater than or equal to one we've already found, we're going to AE. Now the first time it finds a cost for this position, we know that the value is going to be really high. So it definitely is going to make this change, and it's going to say the best cost for I is this test cost, and then it's going to remember who the predecessor was. It says the best predecessor was this one at K. See, that's the value where we found the previous best cost at K. So as in dynamic programming, we have to not only remember the best cost, but how did we get there? We need to know who the previous service center was at, and it was at K. So as it goes around this loop also then, it subtracts 1 from K. It goes further back towards the beginning. It also subtracts 1 from L because its spots are going to go back more to the beginning. And it says if L is less than 2, we go to AG. Well, we never made any for the first 2. They're a very high value. So it doesn't do those. Now, over here, we have 3 examples of the multipliers. Remember, over here it said J was 0, and the multiply vector is at offset J. And we learned that they were 20 apart because down here we saw J had 20 added to it each time. Here are 3 of the values in that list: offset 0, offset at 20, and offset at 40. And when we were back here, we knew that when it was at 0, there were 2 multipliers. Well, here we see they are 10 and 10. At 20, 1 got added, so it was 10, 20, and 10. You might say, well, which service center is charged at 20? It doesn't matter, because we're looking for the best cost. It doesn't matter if we say, well, this service center on this side got the 20, or the one on this side. It's just we have to say that there was a cost of 20. And then the next one, when there are 4, it's 10, 20, 20, and 10. So these are for the charges of the cost between the 2 service centers. Say there's one over here, there's one over here, and this is the cost between them. So that's what it's doing in this loop. It keeps looking back to previous costs it had at offset K, and then adding to it this cost between the 2, which uses this and uses the spot counts, and it sees if that is a better one or not. And it goes around for every position of the service centers, as we saw up here, till it gets to NG. Next it says, well, we have to find the best answer. So we're going to say the n best cost is a high value. Then we're going to set our j to ng. That's going to point to the last service center we did. Then it says for I of 1, and down here it says next I for 10. We're going to go back 10 times to find the best cost. We're going to set ng to I. Now we're at the very beginning. At the very end now. So now, like at the beginning, there is no service center at the very end. So what we have to do is now go back to service centers and charge the cost of getting to that service center starting at the end and going towards the beginning. So each time we're going to go back one more, and since we're going back, we have to say, well, what was the cost of going back? And here we set that up. We set j to ng, so the spot position is the very end. And then we're using our factors at 40. I didn't put that down here, but there's factors at 40. Multiply them times the result values. How many times? I number of times. We sum them up, just like before. Here it subtracts 1 from j. We have to do that every time we go around. And then we say, add the best cost at j to the test cost, and then see if that's greater than equal to the n best cost that we have. If it is, we go to AI, but if it's not, we say this n best cost is set to this test cost, and we have to remember the index where we found it. At the jth position is where we found it. So when we go around here, we're actually starting at the end and finding service centers, and do they have the lowest cost, giving the additional cost to get to the end. Well, once we're done with that, then we know what the n best index was, and we set I equal to that. Then we fill numerically, well, we know this is 60, of the program picked answers with 0. We say there's no service centers anywhere, but then we say set program picked at the ith position to 1, because that's the best position. And this is dynamic programming, so that position remembers who the predecessor was. So here we set I to the best predecessor for that position. Then we check to see if I is greater than 0. If it is, we know that's not the last one because we zeroed them all out, except the ones that got filled. So we go back to AK, and we go around the loop until we get back to the beginning. So we could have many service centers. We go back, another one, another one, another one. Finally, we get to the beginning. This is dynamic programming. We went through it forward, doing our little test to find out what the best possibilities were, and always remembering over here where that previous one was, so we could go backwards through it and get the best answer. Alright, this is the end of the video on Service Center Dynamic Programming Routine.